All right, I'm gonna look through the chat real quick and start with some questions there. All right. I'm not sure who this one's for, perhaps Noah. Will there be a representative on the science team from among those who spent decades mapping the South Pole Aitken Basin?
That's a great question. I- in seeing that question, the internal science team has a number of people who have participated in um, mission proposals for SPA sample return. I look at the center square and my Hollywood squares right here. Dr. Barbara Cohen, we have Sam Lawrence, Ryan, yourself have all worked hard on several proposals to return samples from SPA. And of course, we don't know who will be brought on through the competed geology instrument or participating scientist teams, but certainly already we have a number of people who are quite familiar with the intricacies of the South Pole Aitken Basin. And so I think to answer the question is yes, we will have people who have some SPA awareness who are members of the team, no matter who is selected.
Great. Thanks, Noah. All right, so let's see another question. Sorry, the chat's moving as I'm looking. I think this one might be for Kelsey, Noah, Kadri. Artemis 2's close approach to the moon seems to be much more distant than Apollo 13's flyby. What technical factors drove the selection of this trajectory? You can speak to that.
Yeah, so Artemis 2 is designed primarily to test critical systems like SLS and Orion. So the trajectory chosen for that mission was designed primarily for that. Since Noah and I are obviously focused on the science, it does offer some unique opportunities, so like looking at, full disk viewing and all of the opportunities that affords. So thanks for the question.
Thanks for the answer. All right, I think this one might be for Caroline. Under possible sample high grading, will samples be taken out of their storage container inside HLS? And if so, what kind of analyses would be done?
Actually gonna let Kelsey take that one.
Sure. Yeah. So first of all, on the high grading point, we hope to develop a, science operational and exploration strategy that does not yield too much mass beyond what we know we can return. However, should we end up with more mass than we're allowed to get on board to return, we will not be taking samples out of the bags for analysis on this mission. But again, our going in plan is to not collect more than we can take home.
I think maybe this one is for Caroline. For EVA prep and turnaround, have we consulted parallel industry specialists in like oil and gas, undersea construction, et cetera, from an operations perspective?
We haven't specifically reached out to those organizations, although most of the activities that we're doing during the time are PA specific, and we do feedback from our ISS operators. So the most relevant operational environment is ISS for that, and we constantly bringing in
Okay, thanks, Caroline. All right, looks like I'm gonna ask a question for Craig. Are there plans to communicate the valuable lessons that you've learned from an HMAP to the broader community? And if so, what are those plans?
As far as lessons learned, I don't know that we have any direct plans, although we plan to put all of the data from the mission on the PDS later this year. Science data, as well as all the relevant SPICE files, so you can reconstruct the orbits. We did participate in a meeting with some NASA headquarters representatives on the future of the Simplex program, and some of the lessons learned were conveyed there. But I think that the future of these very small missions is to be determined right now. So I would love to talk to anyone who's interested about that. I know Barbara has a lot of experience with flashlight as well, and the BioSentinel team, and really everyone on Artemis 1 with the CubeSats learned quite a bit, even if the spacecrafts were not heard from. There's a lot of technologies that were developed as part of these that furthered people's careers, and we have technologies that can now be used on future missions, big or small. So I think there's a lot of lessons like that that came out of these programs, and I hope that there's a future for them. This current Simplex program is significantly larger than any of the Artemis cubes, and so I think there'd be a lot that we could all say, not just me, but anyone who's involved with one of these 10 Artemis programs, Artemis CubeSats. I hope there's a forum for that in the future, but I haven't heard of one specifically.
Great, thanks, Craig. Also, apologies, I forgot the H was silent in the map.
Problem.
All right, I want to ask a question for Sergio, since you're still on. And you covered, a little bit of this in your talk, but what, in your opinion, at least, the short version is kind of one of the most exciting science results you've had from BioSentinel? Or technical, if you want to speak to that, either one.
Well, certainly from a technical perspective, we were able, even when the biology and the hardware did not cooperate in the totality of the nominal mission, which ended, a few days ago, we were able still to confirm that all the hardware itself, the optical measurements, the radiation spectrometer, communications, everything was working for the most part nominally and continues to as of right now. I mean, we're encountering some issues like any other spacecraft with the radiation environment over there, but for the most part, everything continues to happen. We have gotten very cool data in terms of radiation, in terms of the environment, the solar particle events, and so on. So that's exciting, and we want to share this again. The expertise of our team, my science team, extends. It doesn't extend past biology and radiation biology. So we want to make this available to the community. So I've been getting requests from third persons, from directly of when are you releasing the data. Even though we do not have such a requirement for this particular mission, we are, because I think it's fair to release this to the community. We can compare this data to our particle experiments at Brookhaven National Lab, Loma Linda University. So we know that we have gotten to a point in terms of total radiation that if the biology would have survived, we might have gotten a response, which is actually what we really wanted to, but we didn't get there, and everything we're learning is going to be applied, or is being already applied to the Leia hardware, which is similar to BioSentinel.
Great, thank you. So we've got a couple more minutes. Caroline, I know you were trying to reconfigure your mic. I'll try asking you another question. We'll see if the audio is a little bit better. Could you talk to us about, if this isn't for you and someone else can jump in, I'm just kind of trying to judge who these questions might be for. How much of an EVA time is kind of maintenance and prep activities versus actual like walking in science? And I don't know, maybe Kelsey or Caroline, I'll let you two figure out who can answer that one.
Sure, I can take that one. Is this any better?
Tiny bit, it's a little bit quiet.
Okay. So I would say that we have a requirement to be able to do about 6 to 8 hours of actual EVA time on the surface. I would think that for Artemis 3, we're looking at 5 to 6 hours probably of EVA time out on the surface. The EVA prep time, there's a requirement for 8 hours of crew time. And that's 2 crews, so a little bit before, a little bit afterward. So probably about 2 hours before, 2 hours afterward for 2 crew members per EVA.
Thanks. All right, I'm going to squeeze in maybe one last question here with the remaining minute. So how much can the science and other ground teams tweak EVAs based on the previous EVA's results? Kelsey, is this for you or Caroline? Again, I'm kind of guessing here.
Sure, I can weigh in and then Caroline can jump in too. Yeah, so part of this and the last question kind of gets at this a little bit as well, is like relationship building and learning each other's languages. So we've been working for a lot of years now to bring in the operations community into our science objectives and for us in the science community understand the operational constraints that we're working in. So first and foremost, building some really powerful relationships there. And that includes a lot of these questions that you're asking, Ryan, right? So while we don't expect, especially on, say, the first crewed surface mission to make wholesale changes to the traverses, we will be able to incorporate, lessons learned in between each EVA and potentially make some smaller scale changes to the pre-planned EVAs based on lessons learned from operating in the suit and the duration that specific tasks take, but also based on the science that we're discovering, right? So we're going to learn a lot of science as we build up EVA time on the lunar surface, and we have pathways in place to get those lessons learned up to the crew and assist them with the small changes that we'll want to make. But Caroline, over to you for filling the gaps.
No, that's all good words. I could envision that the changes that we might make from EVA to EVA would be based on our learned traverse rate. We're going to assume a certain traverse rate before the flight, but we'll really not be able to verify that until we get up there. So if we find out that, you know, we can't go as far as we thought we would, we might have to adjust the plan from there. And then, you know, the mission priorities are going to be pretty well set. So I would expect that if we have a traverse that includes 3 science stations, we might still be able to go to those 3 science stations, but what we do at those science stations may change based on yesterday's EVA. So we'll try to, and that's where we bring in the SIR and the ESO console positions to help us figure out what exactly we want to tell the crew to do at those science stations. Did I say all that right, Kelsey?
Great. Well, thanks everyone. Lots of exciting stuff in the past and in the future coming up.